Hello everyone. Lesson 9. Topic: Introduction to total stations and theodolites. So let's talk about vertical angle. So vertical angle, which are used in slope distance correction or in height determinations, are referenced to the horizon by plus up or minus down angles. The zenith angle or nadir. Zenith and nadir are terms describing points on a celestial sphere. Sphere of infinitely large radius with its center at the center of the Earth. The zenith is directly above the observer and the nadir is directly below the observer. Zenith and nadir and observer are all on the same vertical line. Meridians. A line that means surface of the Earth joining the north and south poles is called a meridian or geographic meridian. All lines of longitude are meridian. The term meridian can be defined more precisely by noting that it is the line formed by the intersection with the Earth's surface of a plane that includes the Earth's axis of rotation. So this is a zero meridian. This is a meridian of point P. This is the Earth's surface. This is a plane of the Greenwich meridian, and this is a geocenter, equator. Horizontal angle are usually measured with the theodolite or total station, whose precision can range from 1 seconds to 20 seconds of arc. Angles can be measured between lines forming a closed traverse, lines forming an open traverse, and a line and a point to aid in the location of that point. Interior angles. You can see a closed traverse showing the interior angles. For all closed polygons of n side, the sum of interior angles will be n minus 2 multiply 180 degrees. The sum of interior angles will be n plus 2 multiply 180 degrees. For 5 side polygon. The sum of interior angles must be 5 minus 2 multiply 180 degrees and equals 540 degrees. In practical field problems, however, the total is usually marginally more or less than n minus 2 multiply 180 degrees. And remember that the exterior angles at each station could have been measured instead of interior angles as shown. So exterior angles at point A of 272 degrees 55 minutes. Deflection angles shown are measured from the prolongation of the back survey line to the forward line. The angles are measured either to the left or to the right. Of the projected line. The direction L or R must be shown along with the numerical value. So here a line on the right and here line on the left. Here line on the right. Prolongation on the right. Also, it's possible to measure the change in direction by directly sighting the back line and turning the angle left or right to the forward line. And let's talk about theodolites. Theodolites, also called transits, are survey instruments designed to measure horizontal and vertical angles precisely. In addition to measuring horizontal and vertical angles, theodolites can also be used to mark out straight and curved lines in the field. Theodolites went through the three distinct evolutionary stages during the 20th century. So the open phase, Vernier-equipped engineers transit, American transit, you can see here. The unclosed optical redoute, theodolites with direct digital redoutes or micrometer-kept redoutes for more precise readings. And also contemporary enclosed electronic theodolites with direct redoutes. So this is a vertical clamp of theodolite. Vertical tangent screw, optical sight, internal switch port, optical plummet, power switch, horizontal tangent screw, plate level, and battery case. And of course, a leveling screw. Here you can see a horizontal and vertical scales with micrometer scales. So horizontal scales 245 degrees and 50 minutes, and plus 3 minutes plus 18 seconds, and total will be this one. Electronic theodolites operate similarly to optical theodolites. On major differences is that this instrument usually have only one motion, up, and accordingly have only the horizontal clamp and slow motion screw. So angle reduced can be to 1 second with precision ranging from 0.5 minutes second to 20 seconds. So this is a typical of more recently introduced theodolites. This display windows for horizontal and vertical angles and located at both the front and rear of many instruments for easy access. Typical specification for electronic theodolites are listed below. Field of view 1.5 degrees, magnification from 26 to 30, shortest viewing distance 1 meter, angle reduced, you already know, angle measurement, electronic and instrument incremental. Level sensitivity, plate bubble, and circular bubble wheel. You can see here. So rotary encoder system for electronic theodolites and transits. This is a rotor and starter, light source, collimator lens, photoelectric converter A and B. Horizontal and vertical angles with an incremental encoder detection system that reads to 1, 5, 10 or 30 seconds. The signal is converted to a pulse signal corresponding to the angle turned, and the pulse signal is passed on to the microprocessor, which displays an angle on the LCD. This is a field notes for angles by repetitions. for closed transfers. This technique effectively removes any error caused by the instrument's vertical hair position, standard imperfections, etc. So you find direct and double station and then calculate that mean and of course error. About procedure to set up a theodolite or total station. So detailed procedure you can see here. And now I explain shorter. So how to set up a total station? First one, total station are used by land surveyors and professional engineers to collect field data to complete their project. There are many different brands of this instrument, but all of them are mounted on 3-legged tripods and must remain completely level at all times for the data to be accurate. Extend all 3 tripod legs to a comfortable height. This is a step 1. Tighten the knobs. Open up the legs to form a triangle on the ground. This is step 1. What is the next? Step 2. Using both hands at all times, place the instrument on the top of the tripod. Gently secure the instrument with the tripod screw underneath. Press all 3 tripod legs firmly into the ground. Very important, raise and or lower each of the tripod legs until the bubble is roughly centered in the circular level. Step 5. For fine tuning, rotate the instrument until it's lined up horizontally with leveling screw A and B, and turn those same screw evenly in opposite direction until the bubble in the plate level is completely centered. Very important. When bubble in the plate level is completely centered. Next step, step 6. Rotate the instrument 90 degrees to perpendicular and repeat step 5. Third leveling screw. You already must rotate until the bubble in the plate level is completely centered and it's lined up horizontally with leveling screw A and B. So you repeat step 5 but using only the third leveling screw instead. This is very important. Only the third leveling screw instead. This is a bubble. Rotate the instrument 90 degrees perpendicular back to the first two leveling screw to double check that the bubble is still centered in the plate level. So, if all this step you are performed, you can use instrument and the instrument already completely set up and ready to use. So to continue on the lesson 10 about theodolites and total station. Bye!